What's up, guys? We are back. Let's go ahead and break out home screen into a package. Let's update the import and let's create a view model. This is where it gets fun. So with the view model, we need to do the @Hilt view model because everything with Hilt needs an entry point. Let's go ahead and do the inject constructor if you're familiar with Dagger. This is very much the same. And let's inject in the API service. Let's have it extend a view model. In the home screen component, we're going to want to add in that view model that we have just created. We're going to pass it as a parameter. Let's remove the clickable implementation here. And we're going to create a friends grid. This is going to be the actual grid that's going to display with all the content that we get from that JSON file that we pull down. Okay, it needs to be a composable, and we're going to pass in a list. Keep in mind with composables, this is going to, there's an auto magic part of composables. So every time that a field changes here, and as long as we're using state and mutable state, then Compose knows how to do the auto magic hookup so that whenever it changes value, it's then going to go ahead and recompose this composable and pass in that new value. So we have, which is why in view models, we want to use state and mutable state in the view models. And then basically we just have it react or listen to those changes here in the composable UI. There again, that is another separation of concerns. This is also a reactive type pattern. And if you've done React in the past, you're going to be familiar with this as well. All right, let's create the friends UI model itself. This is also going to be a data class. Again, single responsibility here. It should just be a data class that holds exactly that information and not other information and doesn't do other functions or mutations on that data itself. The only purpose of this is to represent a specific state that we are going to render on the UI in this case. Remember our data model we have in the networking layer or the data layer, that has a lot more information. However, here in the grid, we don't need to know anything about the actual full URL. We don't need to know the description. We don't need to know the other information. We just need to know the name, the thumbnail URL, and the ID. What we're going to end up doing ultimately is we're going to pass around that ID so that when you click on a grid item or card item here in the grid, then we're going to pass that ID over to the details page, and it's going to use that ID to look up the data that we need. That way we're passing very little information instead of passing over an entire object. Okay, and here we'll just go with friends EmptyList at the moment. This is another added benefit to the way that we have this set up. Specifically, again, it is separation of concerns. You see, we have the view model, which is going to handle all of the actual view model transformations. The purpose of a view model effectively takes the data from some other location. So it could be a networking layer, it could be the repository layer. What you're doing is you're taking that data and you are transforming that data into something that's usable for that view. So it shouldn't be generic data that can be used for multiple views. It should be tied to a specific view and should be mutating or mapping that data specifically to that view and the way that that view is going to use it, which is why here, the state that we were just talking about, we're going to go ahead and create this thing called friend state. It's a mutable state that's private. So another thing that you want to keep in mind, it's a little bit more on the encapsulation side of things. So you don't want to be able to mutate the state outside of the view model. You want the view model's responsibility to handle the state, the view model handle the transformation. So the mutable aspect of the friends state or of the variables that we have in here of the data, that mutable aspect should be private, always held as private. It's a coding convention where we put the underscore beforehand. It just represents it's a private variable here within the view model, and that should only be mutated here within the view model. However, we need to expose the changes to our UI layer. So to the actual view itself, the composable. And the way we do this is we create a state. So state is not mutable. State is just, it's going to be the same representation. It's going to be a list of friend item UI model, but it's not mutable. And we're just going to set this to the value of the mutable friend state. That way the mutable one stays private and the non-mutable one is exposed and is consumed in our composable or in the view layer. Now, when we come back here where we have this empty list, we can actually drop in from our view model. And this will be the friend state. And we want to listen to the value. Again, this is part of that auto magic that Compose gives us. So Compose is now going to listen to the ViewModel.friendState.value. So the value, anytime the value changes, Compose is going to auto magic go through here and say, hey, that changed, and we're just going to go ahead and update that. Another advantage to the way we have this set up is we can actually create mock data. We don't need a back end in place for this. We just need a representation that's going to be something similar to what the backend actually is. Well, it has to be exactly what the backend actually will be. We'll just go ahead and create this mock data real quick. I'll show you how to do that. This is another advantage to the way that we have these abstractions set up. This also proves that by separating out the networking layer, you can go ahead and rip it out later if you want to and drop in a whole entire different networking data layer if you would like to with relative ease. The other advantage to this, and this is a talking point when this is a talking point in interviews, is dependency injection. And this sort of abstraction and the inversion control allows you to be able to have, say, an engineer work on the front end completely independent with the back end. So the back end may not even be set up yet. They may not even have it developed. And you can have the front end engineer go ahead and implement it entirely without having the back end, without having to wait on a dependency of the back end to actually go ahead and build their aspect. And you can then have another engineer, you can have an Android engineer go ahead and build out the back end at the same time the UI is being built out without either one interfering with each other. Because the data layer, again, is going to be returning a data model that is specific for that data layer. You want to map that over to the UI layer to be consumed in the UI layer. So it doesn't matter where that data is actually coming from. You're transforming it here in the view model anyway. So let's just go ahead and drop in these values, just copy paste from that JSON file that we have, and I will show you how this works. Another way you can do this, and looks really good for a coding challenge, it demonstrates your knowledge of dependency injection, is you can actually set up a secondary API service. So the API service implementation, you can create a mock API service implementation or something along those lines, and just go ahead and hard code this data in there. They'll have the same signature because it's using an interface, which again, follows along really with Liskow's principle, the interface segregation principle, and is a huge advantage to dependency injection in general. So you can just swap out one of these implementations with another implementation, and they're going to be able to swap in and out perfectly without the consumer even knowing which one it's consuming. And that's one of the huge benefits to dependency injection. And Hilt makes that super simple to do. I'm not going to do that here. I'm just going to hard code it for the development aspect of it. Later on in another future episode, I'll show you how to create a mock service as well. As far as talking points in an interview, you can also talk about how dependency injection helps you with the testing aspect. Because again, you can go ahead and create a test API service, one that's not actually going to hit the endpoints, but is just going to go ahead and give you that data to be able to test to see if the view models transform the data properly. All right, coming back over to the friends grid now, we want to create a LazyVerticalGrid. And let's go ahead and give it a grid cells, adaptive, min size 128.dp. Okay, and we're just going to loop through these items real quick. Can grab the index, the friend component. We're going to create a friend component to handle each one of these things. And again, I'm keeping these functions super small. It's just one thing that they're responsible for. Again, one thing they're responsible for. We're coming back to solid constantly. So single responsibility principle. And here we're going to have a composable, which is going to represent the friend component. And we're just going to pass in the friend, which is the friend item UI model. We're passing that in from when we're looping through all of the items that we have that we got from the view model. So again, ViewModel is going to hit the data layer. Data layer is going to kick back a data object. ViewModel is going to transform the data object into a UI model. It's going to keep a list of the UI models. It's going to keep it in a mutable state. The UI is going to listen to a state version of the friends list. And then it's going to go ahead and update this. So now as we're looping through and we're grabbing each one of those items, it's now going to populate each one of those friends separately right here, broken down individually. This friend that's passed in is just one friend object. We're going to have to pass in the lambda to handle the on-click, which is the on-navigate to detail screen. And let's wrap this in a material card. And, let's just give it a height of 250 dp. That will look nice. Okay, fill max width. Padding of 8. Now, these components that I'm creating here, there's a friend component, the friend name, and we're going to create all of these, the friend image, all of these ones. Really, you can make them private, and I would probably recommend making them private. I'm just going to keep them open here. Just because it's another area that could be a low-hanging fruit talking point. It's also an area that could be debated in the industry right now, because then the question is, where do you group them? Do you group them in one file, as I've done here, where you have home screen and you just have one file and you have them all listed out as functions within the file? Or do you split them into their own specific file, where you end up with another file called friend component, another one called friend name, another one called friend image? Or do you just leave them here in this file? The other thing you can do too, and this is a little bit more common, you'll find, is say friend name. You might start to see the pattern that's a reusable component throughout the app. And you actually might want to abstract that completely, which you're doing the abstraction here. So we're doing the abstraction here, and we're going to go ahead and break it out into its own function. But you can go one step further, and you could break it out and take it into and style it specifically with the theme of the app and put it into our core UI module. That way, all of our modules in the entire app can consume this later as a component that we've created. Okay. Now that we've got the friend name, we're passing in the name, and friend image, we're passing in the image. Again, everything in Compose really is rows and columns. Pre-rows and columns, we like to use constraint layout. Constraint layout was a lifesaver when they came out with it, but Android no longer uses views. So it's now composables, which I'll do another episode again to explain what the differences are and the huge advantages and why Google even rewrote. In fact, just go to Google and they'll tell you. They said it in Google I/O almost like 2 years ago, where they explained why they even fundamentally had to go in and redo how Android handles the view layer in the first place. With that said, it's now rows and columns. And we will add in the text in here. And this is basically just a text that's going to display the name. Let's go ahead and give it an 18 size font, semi-bold weight, and let's center that text. For the color, again, remember it's important to use the color schemes and not the actual color itself. Let's make this tertiary. Padding, let's give it 8 dp. Why not? The left and right, it's really not going to matter. We could just do top and bottom padding. Okay, coming down to the friend image. Here is where we're going to import another library. All of these dependencies that I am importing, I will post a link in the description, so you can quickly click on them and find the links to these dependencies as well. Friend image. So we're going to want to center it within the space that's left within the card. So we'll wrap it in a column first. Which means we could just do the fill max size, give it a vertical arrangement to center it, and then we will do the same thing on the horizontal by doing a horizontal alignment. All right. And now we are going to find that library that we need to add. All right, when we come to Google's documents for Jetpack Compose, they actually recommend either Coil or Glide. And in their docs here, they're showing Coil. So this is probably the easier one to set up anyway. So you can do like 2 lines. Let me go ahead and grab this and show you how simple that is. All right. Drop in the implementation, sync the project, and now we can just simply copy that code, which you'll notice is the same on the documentation side as it is on the Android Google documentation side. Coil and Google syncing up nicely. All right, drop it right in here. Go ahead and import the async image, and let's change that URL. See, we're passing in the URL from the object that we got from the server. We're just going to drop that in here as the string, and let's give it a content description. Let's just say thumbnail for image. These are going to be used for accessibility purposes, so that's something you can bring up in the interview when you're talking about it. So these, you should actually make these a little bit more specific for the image that is being rendered. Maybe even have an accessibility tag that's set down from your server so that you talk to the API team about. This is for a coding challenge, in which case, unless it is specifically for a role that is built on accessibility, I wouldn't bother implementing much more than putting it there as a note to talk about when reviewing the code. All right, let's come back up and hook up the clicking aspect. All right, let's come back up and pass down the on navigate to details screen. And let's do named params here. I like named params. When we run, okay, we got an error. What did we break? It says no value passed for ViewModel. That's right, because home screen now requires a ViewModel. So let's go ahead and leverage Hilt to inject in that ViewModel for us. And this is how simple it is to do with Hilt. Check it out. ViewModel equals Hilt ViewModel. That's it. Hilt is smart enough to, well, Kotlin is smart enough to know what type of class that's required because we define it over there on the ViewModel. Oh, also another very important point, main activity in order to use Hilt is going to need to be an Android entry point. Let's go ahead and take care of that right now before I forget. Also, we're starting to talk networking. So let's go ahead and give the permissions now for the internet. We're going to need that. Otherwise, that will throw us an error in the future as well. Now, that's just simply one-liner. You can Google this if you want. I'm sure if you have done any Android work, you have seen this line before. One more dependency I forgot to add in here, and this is going to break it if we don't add it, is Navigation Compose, because we are using Navigation Compose in Jetpack Compose, navigation component. So in order for this to work properly, especially with using Hilt, we are going to need to add this dependency here. Just simply implementations, sync. As a quick test, let's just go ahead and run it. We should see the mock data should be displaying up here. Let's see. Yep, there we go. Oh, and an important thing to note, we are using the emulator here. I'm about to switch over to a real device for this purpose, but you'll see the images should be displaying here. In fact, there's even space for the images here. They're successfully working. However, the async image from Coil doesn't always display on an emulator. So one thing to note, sometimes when you're developing, just switch to a real device. But otherwise, we have our grid component here looking nice, showing us the data that we wanted it to show. Okay, so let's actually hook up some live data now. Let's go in here and remove the mock data. And we're going to go mutable state of, and we're going to do empty list. Here's another great talking point as well that you can highlight in a coding challenge where we're using EmptyList instead of ListOf. So some examples out there you'll see, say on Stack Overflow or Medium, you'll see people just using ListOf, open, close, parentheses. It is slightly more optimal to use EmptyList, and it's recommended to use EmptyList. That's why they gave us EmptyList. EmptyList is effectively a singleton reference, or reference to a singleton of an empty list. Whereas when you do ListOf, you're actually creating a new implementation. You're creating a new object, which is of an empty list, and then you're going to recreate that every time you run it. So it's slightly more efficient to just go ahead and reference the singleton version that already exists for us. Is your device going to slow down if you use ListOf instead of EmptyList? No, not at all. However, it looks nicer and it shows that you know what's going on here. All right, now we're going to talk coroutines. Coroutines are a very important part to Android today in the industry. If you don't know coroutines, you're going to want to know coroutines going into an interview, and this is just going to be a simple implementation of coroutines, which is going to demonstrate we know how to use them. ViewModel scope.launch, and remember that safe call that we wrote? This is now how we're going to implement the safe call here, and we're basically with a one line, we're going to be able to get the response from Retrofit, and it's going to be wrapped in the way we want it to be wrapped. So when we look here, it's just when val result equals safe call, API service.getFriends, we're going to run that. And let's let Android Studio create the types for us. So remember how we wanted a success, an exception, and a failure. Now we have all those statements or all those cases here in a when block for us. So when it's success, remember we have the data aspect. Again, this is the power of sealed classes. We can now reference data straight from result, and we're going to go ahead and set that to our friend state.value, which is the mutable state, in which case our state, the non-mutable version, is going to update based off of what our mutable state just changed to, which means our UI component, which is listening to this, and will automatically update, and the components in their compose is going to take care of that automatically and update and re-render those functions that we need to re-render based off this new data that just came in. Remember, the purpose of a view model is to transform the data from one layer into the other layer that we're actually using it at. So in this case, we have a response that's coming from the server, and that is going to be a data layer or networking layer type model. And we do not want to use that in our UI. You should never use that in your UI. When data moves from one layer to another layer, it should be a separate model to represent that data. Again, that separation of concerns, then you're going to have something that maps them together. So some people like to separate this out into a separate mapper file, or even doing a shorthand version at the end here, the view model. Just keep in mind the purpose of a view model is transforming that data. So I'm just going to leave it right here, where all we're going to do is we're looping through this, well, using a map to loop through it, which then gives us the data value, and then we're going to transform it and kick back out the friend item UI model. And this is a great talking point as well to explain that you like to keep the data pure within the layers that you're working on, which means data is pure, is a pure representation of the data and what is used or consumed or necessary for the data layer. And the data models on the UI side or on the view side are strictly representations of what is needed for that specific view. This is clean architecture. All right, now let's go ahead and come back over. Remember how we had to do in our API service implementation? Let's go ahead and actually implement that line, which is just simply one line. So all we have to do is now return API functions.getFriends. And yes, we can make this into one liner if we want, but I'm going to use this for something else here in just a few moments. So let's leave it as a return. Okay, let's fill out the exception or the failure. And in fact, this is a great opportunity as well for you to leave low-hanging fruit. You can either handle an actual exception here and maybe update the UI based off of it or the failure based off of it. But instead, what I like to do in this type of situation is, again, we're not going for 100% perfection or 100% complete answer. What we're doing is we're showing that the breadth of the knowledge that we have. So we have one case, the success case, which is actually going to update the UI and transform and everything based off of that. However, now for the exception, all we have to do is throw a simple log statement here that says, we have an exception, we'll handle it here. You can throw in a comment saying that this in an enterprise system would be handled and should be handled this way. This gives you a great opportunity to talk during the interview when you're explaining your code and why you chose certain ways. You can then go ahead and talk about how you like to handle error handling in general. That's also a very heavily debated topic. I have a few ways that I like to do it, and they're pretty clean, pretty simple everywhere that I've been, and I've introduced them to this. They love it. So stay tuned to a future episode where I will show you exactly how to do that as well. So by just creating a log statement here, instead, what it does is it shows the interviewee that you know how to implement this, and allows you to then talk through the next points. It's like pseudo coding for an interview purpose. All right, let's run the app, and sure enough, we have the data. This is now on a real device here. By the way, Vysor, I highly recommend using Vysor if you're in the industry for any length of time. You're definitely going to need to display your phone on a screen, and Vysor, I have found it to be the best one. I pay for the professional version. All right, let's now hook up the actual clicking event. So what we're going to do is we want to pass back the ID. So when you click on one of these grid items, we want to pass back the ID so that the nav controller can then open up the details based off of that ID that we pass it. So all we're doing is in the Lambda, we are adding the string. And that just means it's going to expect a string to be passed in when we actually set this, when we actually invoke the function. We can just do the command click to get into the next usage. There we go. Let's add in clickable. So on the actual friend component, which is the card. So on the card itself, if you click on it, we want to add the clickable, and we're just going to pass back that friend ID. Now, because we added string to each one of these lambdas, we can check this out. See how it goes all the way up, each higher order, all the way up until we see the home screen. We can click on it and have it tell us where it is in the NavHost. Here we are. Notice we now have, at the end of this lambda, it string. This is actually the ID. This is the ID that we just passed in. We now have that available here. So let's go ahead and just call it ID. And this is another aspect. It's just a simple aspect of us demonstrating to the interviewee that we understand JetPack navigation. The way JetPack works is it appends strings. So it's like a route, sort of like a URL. And we go ahead and add on these effectively get params. In this case, just ID is all we're going to do. There are some downsides to this. For example, and I've run into them in the industry. For example, what if you had to pass a URL to a route? Yeah, that's a nightmare for it to try to sort out. So again, that's one of the downsides to using the nav component that Google gives us through JetPack Compose. However, there are ways around it. You can write your own, and they have given us all of the tools that we need to in order to be able to write our own. And I will show you that in a later video when I show you how to abstract out all of the navigation components so that you can drop it in anywhere you want. Now, we need to change the route of the details as well so that it can accept the param. So in this case, we're going to call it profile ID. And we put in the curly brackets. That signifies to the nav graph that this is a param that is being passed in. And I like name params. So again, I lost those here somewhere. Don't know how I did that. Anyway, adding them back in. Arguments. We just pass in the arguments ListOf. This is going to tell the nav graph, or this is going to tell the nav host what we think profile ID should be. In this case, we're going to call it a type string. By default, they're type string. But in this case, we're going to explicitly state it as a type string. Now we have a backstack entry here that we can go ahead and reference, and we can use to pull out that data that was just passed to it. Now, what we do is we just go with the arguments.getString. Notice this is a nullable. So let's go ahead and throw an exception if we aren't passing something in. This is actually in my opinion, it's a good practice to do. And this is a great talking point as well if you're in the interview and you're explaining your code why you did this. This has to do with failing fast, covering gracefully, but really it's about the failing fast part here. What we want to do is make sure that we're always passing to the screen some sort of profile ID, because we can't load the details of a profile without a profile ID. That's violating the fundamental architecture of our app and how we have this set up. There's no business use case for that. So some people like to suppress these errors or make it, sort of work, where then you'll just be sending in blank data or something along those lines. But imagine the user experience. You have an app. All right, you're scrolling through, you click on one of these details and there's some sort of error. A developer forgot to send it in this case. Then you go to the detail screen and you see a blank screen. Well, now this is a bug. How is that any better than the user getting an error message says, oh, sorry, this wasn't sent right, and then it crashes, reopens, and now your data is in a proper state. The huge advantage to this, though, is you, as the developer, are going to catch this. If you throw here, that's going to be caught before it ever goes into production. So the chances of you running this scenario in production, slim to none. Especially if you have all your test cases set up and you run through proper QA and everything like that, because you're going to see right off the bat when you're developing and you go ahead and you pull out an ID and you pass it in here. If that ID was null and you pass in a null object here, it's going to look through and say, hey, whatever you just did there, whatever you just developed 5 minutes ago is fresh in your mind. That was wrong. So you can go back and say, oh, right, that's null here. I can't pass in a null. I need to actually pass in a value. That's one of the advantages to fail fast. And that's one of the things that you can talk about here is fail fast. In this case, it's just going to show out saying profile ID must be passed as an argument, and it's not. So you'll be able to see that in the logs too when you come into here and don't pass in an ID. All right, now detail screen, we're going to pass the ID to detail screen and we're going to hook it up with a ViewModel. Right now, neither of those exist as parameters, which is why they are red. Now, we want to go ahead and create them. So simply ID and ViewModel. Let's head on back on over to detail screen and let's make sure that we can pass in an ID, which is a string, and then a ViewModel, which we will create the detail screen ViewModel. Now we haven't created this yet, so it is also going to be red, and let's just call it details screen ViewModel. Very fitting name. All right, let's copy that name, come back over here. And in fact, let's make a separate package for details, just like we did for home. That way we can keep all of the details screen classes together, nice and neat. Just drag, drop, refactor. And let's add in our detail screen ViewModel right here, paste because we copied it. Cool. Now, this ViewModel is going to look very similar to what we just did for the home screen one in the setup. Has to be a Hilt ViewModel, and then we inject in a constructor. And again, this is going to need the API service. And now we can change our package, and we have our detail screen ViewModel here, which also means we are now happy back in our nav graph because now the ID and ViewModel parameters exist. All right, cool thing here, LaunchedEffect. Remember how on the previous ViewModel we used init? That way it comes in when the ViewModel loads, the init runs, and then it goes ahead and kicks off the ViewModel scoped coroutine to make the network call to bring the data back. In this case, we're going to use LaunchedEffect. This also, again, demonstrates the breadth of the knowledge as opposed to the depth of the knowledge on these areas. So when you're talking about this for the interviewer, and you can explain the reasons why you did this. LaunchedEffect is a way of kicking off a coroutine within a composable. And in this case, we need it this way because we're going to have to marry up this ID that we just passed in into the ViewModel. And then we're going to have to make the ViewModel then make some sort of call, network call, or something along those lines in order to get the data related to that specific ID. Now, we can't do that if we just say init because we're not injecting it in and Hilt's not going to know what ID to pass into that ViewModel. I mean, there's ways of going ahead and doing that, but it gets really complicated very fast. So instead, what's better is just go ahead and pass in the LaunchedEffect or use LaunchedEffect here, pass the ID to the composable. That way, if the ID ever changes, as well, shown it changed. But if it ever did change, this would go ahead and re-render. It's going to go ahead and kick off. And what we're going to do here is we're just going to create a function within our ViewModel. We're going to call it load profile for ID. And we're going to pass in the ID, and you know what? Let's let Android Studio create that function for us. It's always best to leverage, well, not always, but oftentimes it's best to leverage Android Studio's little helpers to make our lives so much easier. So now in here, we have the ID. We're now in the ViewModel. ViewModel is created, and we have an ID, which we can go ahead and make this call. Now, this, remember when I talked about the repository pattern earlier and how we're going to handle these things? A lot of times in a code challenge, you're not going to have an elaborate API. You're just hitting like a list, and then they want you to go through and find this, a value in there or whatnot. So ideally, we would have a one endpoint which goes ahead and gives us the list that we have available. Then we'll have another one where we hit and we say get profile for ID, and then the network call or the server would then tell us what that information is for that, and we can break that down specifically like that. However, in this case, we're not given that. And again, keep in mind, coding challenges are intentionally vague, and it's an opportunity for you to shine. So what you can do here is you can structure this with a repository pattern if you want. So you hit the endpoint, you get the data, you go ahead and you write it out to a database, say room in this case, and then when you come back in here and you want to get the profile for that, you just go ahead and search your database and say, hey, do I have access to it? Do I know something that has the ID of whatever I'm passing in here? And you can pull out that specific entry and drop it back in here and pretend as if it actually hit the endpoint. And actually, there's some apps out there in production that work this way in a production environment. However, there's also some drawbacks to that. And you can talk about the drawbacks to that. You can, at this point, you can bring up and say that a repository pattern has a issue of potentially having stale data. And why do you have stale data? Well, that's because if you go and you hit a server and then you just write a local copy of that, now you come back into your repository and you say, hey, repository, tell me where to get that data. It's going to look and say, hey, I have some data. But how do you know if that data is the same as on the server? You won't know unless you hit the server. So that presents a potential issue of stale data. If you always hit what you had stored locally and the server updates, then you're not going to be getting the updated version. You're only going to get this locally cached version. That's where if you use HTTP protocol 304, no change, basically what that does is you also have to have the server that is set up for it as well. Basically what you would be doing is you would be hitting your repository or your networking layer and say, hey, server, tell me what this value is for, here's my get call. All right, cool. You get all this data down. And now when you come back in, you say, hey, server, tell me what that is. And then it comes back and says, nothing's changed. So it just kicks back at 304, which means nothing changed. So now you know nothing's changed. I'm going to go ahead and use my local copy that I have here. Now, one of the things, this is why it's a really good talking point here in an Android interview, is a lot of companies don't have this set up. Many people out there don't even know that, even though this is the protocol that came out in the first versions of HTTP. It has been around 20 years. But what's cool is Android knows this. So we added in HTTP 3 and we added in the cache, and Retrofit is configured to go ahead and use HTTP 3 as its cache in order to be able to handle this. And it will handle that automatically under the scenes. So you don't have to implement that really on the Android side. It's going to be taken care of for you. It's really just the server side that has to be changed in order to handle this. So there's also an e-tag component. Basically, you're sending off an e-tag, and along with your request, your GET request, and the server looks at the e-tag. It has it saved, has the last request saved, and matches up to see if there's any change and kicks back that result of a 304 if there's no change. That's all handled for you. These are great talking points in an interview because it shows that you fundamentally understand these aspects, and most likely, in the industry right now, almost no one is using that. So most likely, they probably haven't done that yet. Also, no, that's going to be a losing argument when you get into the company. You're not going to be able to get the company to overnight change to using this, even though it's an awesome way of handling caching, and you can eliminate the need for a repository entirely. And the improvement is less data is being sent back and forth, as well as guaranteed non-stale data, which is kind of important when you're talking about data. A question that sometimes gets brought up is, what if you don't have a network connection. Well, simple. If you don't have a network connection in the initial request, you're not going to get a response. That's going to happen no matter how you have this set up. Now, Retrofit and OK HTTP, they have it built in within the cache, and it is smart enough to know when it hits the server and says, hey, I should be getting a response. I'm not getting any sort of response. Then it goes back and says, do I have a local copy? Which means a combination of Retrofit and OK HTTP3, you already have a repository pattern built into the app that you don't have to build. Awesome. That's a great talking point. In reality, you're almost never going to actually get the opportunity to implement this, unfortunately, and you're going to have to build out your own repository. But right now, we're talking about how to land that job. We're talking about a coding challenge. So that's why it's important to note here. And it's important to bring up, proactively bring it up. All right, so in this case, what we're going to do is we're going to build out the state. Now, notice in this case, well, first of all, friend's UI model is not built yet, so it's going to be red. But notice it is a nullable. I hate making this a nullable. There's ways around that. I'll show you in later videos as well. Stay tuned. I'm just going to walk through every aspect of Android for you. I really am. I'm going to break it all down for you. If you want to be a senior dev, subscribe to my videos, watch my videos, and I'll make you a senior dev in almost no time. The reason I hate doing this is because I strictly do not like things being null. I think that everything should be deterministic. These are great talking points in interview too. Everything should be deterministic where you always know a value, you always have a value, and not just, oh, if it's a nullable or not nullable, or if it's in a null state, and then using null as a state. I try to avoid using null as a state if ever possible. And Kotlin has lots of really nice things built in to make this so much easier for us. So remember earlier when we used a sealed class to handle the API response of our safe call on the networking side? That's what I like to leverage here as well. I like to create another sealed class that basically represents a loading state. So you can have something that represents loading, something like success and failure. There's a few other states that you might find useful, but those are basically the main ones that you'd be looking for there. And then by implementing that, we don't need a nullable here because you would never set to null. You would set it to state.loading, and then you'd be able to render the UI based off of what a loading state would look like in this case. However, that's going to be a little bit more work, and we've already shown that we know how to use sealed classes, so we can go ahead and put a nullable in here, and that is also low-hanging fruit that an interviewer is going to ask, hey, why do you use the nullable here? And then that lets you talk about and say, hey, I've already used the sealed class once. I would use something very similar to what I did there, and I would do it here, but I would use it to create a loading state, and then based off of that, we could determine what the state of the app is in the loading aspect on the UI side. And I would recommend not reusing the one you have for APIs, for API response. Don't reuse that because that is an API state only. In this case, we're talking about a UI state, which the API state and the UI state are different. For example, there's a loading state. You need to know how to handle a loading state on a UI side. A network call, that's fundamentally built in. You know you're in a loading state if you made the response and you don't have a response back yet. Done. You don't have to include that in the sealed class on the API response, whereas you have to include that on the UI if you want to handle some sort of loading state. But let's go ahead and create the friend UI model right now. Again, this is going to be a data class. Again, single responsibility here is just going to be a data class that represents the friend, the profile, the friend UI model of that specific page on the details. That's it. So in this case, all we need is name. We're going to need an image URL. We'll care that's the full image or the thumbnail here. We're going to go ahead and set that to the full image, but this name should match what we're displaying. So we're displaying an image URL. It makes sense to just call it image URL. Now in here, under the load profile for response or load profile for ID, we're going to want to hit the API service, and we're going to want to be able to say, get a friend with a specific ID. That function doesn't exist yet. So it's going to be red. That's what we're going to build. And we're going to have it set to eval response. Now let's go ahead and create this function. Let's leverage Android Studio to create the member function for us. Okay, create a little more data than we needed to. Let's go back. We don't want it to be we actually want it to be a friend response. In this case, that friend response is the same friend response that we already have for get friends. It's in the data layer, so we're fine with that. Let's implement the missing members. Now, here's where the conversation about repository really matters. So we don't have an endpoint we can hit that says get friend and it pulls it down. All we have is what we already called of these get friends. So what we're going to do is, for the time being, private. We're just going to create locally. We're just going to create a copy of the friends when we go ahead and we pull it down. I'm also going to explain to you why this is a bad idea in production, but works okay for a coding challenge. So what we do is we have a list here. It's a var. Also, I like using vals everywhere we can. So the fact that we're using a var is code smell. But in this case, it's a coding challenge. We're going to set it to an empty list right now. And now this is why we made the API functions for get friends. We kept it in here as a return instead of making a one-liner, because now we can just say and also or dot also, and we'll just set, as long as, because the response can be null, we're going to check to make sure the response is not null. And if it's not null, we're just going to go ahead and set friends to the body. See, we can make this a one-liner, but now it looks kind of ugly. So we'll just leave it with a return. Either one looks ugly. All right, so now we have a local copy, or in theory, we have a local copy. I'll explain why you can't guarantee that you have a local copy here. And we'll go ahead and do find. This also, again, remember how I was saying, don't rewrite a binary search, just leverage these, just lever a collections operator here. It is good with a coding challenge to throw in that you know and understand the collections operators. They give them to us for a reason. So in this case, let's just go ahead and do a find, which is just going to go through and find the first element that matches this. In this case, we're matching the IDs. We pass in the ID, so it's going to go through that list and say, hey, if there is an ID that matches the same ID, go ahead and kick it back. However, if there isn't any, if it searches through and it doesn't find any, or it's an empty list, then that will be null. So again, we want it to fail fast in this case. We want to throw an error, throw an exception. It's an illegal state exception that says we can't find that ID, and we're going to crash. Now, what this does, however, the downside and limitations to structuring it this way is we are forcing a specific flow, and we're assuming that flow was made. So what we're doing is we're saying, hey, get friends is always going to be called before we show the details, which in theory, that sounds great, but in production, it's going to fail several times. So for coding challenge, it works just fine. However, this is also another low-hanging fruit, whereas the interviewer might be smart and be like, yeah, you know what? I wonder if they thought about this. And then they can ask you about it, and you could just proactively explain exactly why this is a downfall and the proper solution, which would eliminate this. But again, it's just a talking point. You don't actually have to code it for a coding challenge. Now, the issue here is we are making the assumption you've gone from the list to the details, from the master to details. Now, what happens? I mean, that is how you're going to get the details. But let's say you go there, details, it's displaying just fine. You exit the app, you let it sit there in the background for a while, and then you come back in. Now what happens? Let's say there's a configuration change. Now what happens? Well, what's going to happen is your singletons are going to be erased from the configuration change, and you're not going to have that same list here because that was just stored in memory because it was wiped out. This is also a situation where you background the app and the Android device now is consuming so much RAM. It says, I'm going to start killing apps in the back, which it does that when it wants to try to regain its resources. So it chooses this app and says, goodbye app. Now, when you come back in and you are on the details screen, remember, you are on details. It's going to go ahead and try to recreate details. It's going to pass in and say, oh, okay, well, cool. You know, we have the singleton references to the service. We have all these things. That's cool. That's cool. That's cool. Now you've got it, and you can't guarantee that you have that ID. And so it's going to come in here, it's going to try to load off of an ID that doesn't exist, and it's going to throw that error. So that's a downfall with this specific way if you're going into production. So if you're doing a production, don't do this. But for coding challenge, it works just fine. Okay, now we can come back over to our ViewModel, and response is we're hitting the API service, and you're going to go ahead and get the friend. It's going to come back. And now all we have to do is we just have to update our mutable state to match what the friend is that we found. Remember, if it didn't find one, it would have already thrown, and the error that would have thrown would have been in the service layer. So in this case, if it's right here, we know response actually exists. So all we have to do, again, ViewModel maps. It transforms data. That's the purpose of a ViewModel. Emphasize that when you're explaining this to whoever you have built this coding challenge for. The purpose of a ViewModel is to transform the data from the data layer to the UI for that specific UI. So we have a response, which is of a data type representing for friends. We want a friends UI model. So we just simply map it here. We go ahead and we create a friends UI model. And we have all the values from response, and we only need to map in what we actually want. We don't care about the thumbnail here. We don't care about the ID here, even for that matter. We already have the ID that was passed in the signature here of this function anyway. So here we're going to go ahead and map to the Kotlin looking naming convention for image URL, and we're going to go ahead and pass in what we did here with the image URL full from the JSON value. Now, when we come back and we look at ViewModel in the details screen, that's happy now. We have the details ViewModel. Now, let's do something with this data. So we're going to go for a card. And padding 8, give it a fill max. And let's go ahead and have Compose listen to that change of the view model. So in the view model, we have the friend, which is a state. So we're just going to listen to that non-mutable state. I know, listen to a non-mutable. It will update because it is listening itself to the mutable one. So we're going to set the value, and we're going to let Compose re-render this whenever that value changes, because it's state, and it auto magically does that for us. Now, we're going to create a friend component. Remember how I was saying we should have probably made the other ones private? This is why we should have made it private. See, now when we're over here and we're looking at friend component, we're going to create a friend component, but it thinks that we can import the one from the other one, but we're actually going to make it slightly different. Again, you can abstract those out into a core UI if you would like, and then be able to reuse them all throughout the app. That is the proper solution for production type app, but this is a coding challenge. So we're going to create a friend component here. Now in friend component, see, now the red line went away from friend component. We didn't have to import it because we now created it here. It's a composable, and we're going to have a friend name at the top. We're going to have a friend description. And this one did not exist in the previous one, so it's just going to be red and not even try to make us import it. Friend.description. You know what? Let's throw in a divider. Again, this divider is going to look very similar to one we just used. In fact, we could copy paste it from the other one if we really wanted to. Color, we're going to set it to the material theme color. Again, for the same reasons we said before, because if you're switching from dark mode to light mode or accessibility colors. And now we're going to want to actually load the image as well, friend image. And again, same name as what was on the other file. So it thinks we can import it. We can't. We don't want to import it. We're going to write one here. Okay, URL, friend.image URL. And let's just go ahead and create these composables down here. We have friend name, takes in a name. We have friend description, takes in a description. These are strings. Friend image takes in URL, which is also a string. And now see, all the red went away. We didn't have to import anything. Now let's just go ahead and copy these because we already built them once. Let's copy them and just change them to what we actually want. So let's see. And the fact that we're copying and pasting them suggests that we should probably be moving them into a core UI module, which go ahead and do that if you want for bonus points. Okay, let's actually increase the font size. Let's just make it 24 in here. Set it apart, make it worth it. No, let's just keep it 18. It's going to look ugly as 24. All right, let's copy this down into description because it will be very similar to what we need. But this one, we're going to have it smaller font, and we're going to set the description, and let's set it to a 12 space. And the image, we did that over here as well. So this is literally just copy paste right here. And now we have the async image ready to go. Match up the URL. And now, as you see, we have all of the data here. Let's scroll down to the bottom one and let's click on Puma, Beach Puma. Be like Puma sometimes. Just take a beach day. We can all take a page from Puma's book. Puma's like the best dog ever. All right. So if we click on it, you see it actually pulls up the details. Now check this out. When we load it, see how it waits a second before it loads the image? It's because we built it, or we have caching in there. So if it's a new image, now we come back to the one that we did before and it loads immediately. That's because it's pulling up the cached version of that. Any of the ones we've loaded up already, it's going to quickly load up. Piper, OG. See, there's a little delay, but then we come back in very fast. Same with Poppy. Delay until we come back in. Froppy, already there, good to go. And Piper takes a second, loads up. Come back down to the first one we chose. It's still in cache and it can load up instantly. And that, my friends, is how to ace a coding challenge. What we've done here effectively is we've broken out all of the components of a very simple task. And as you see, you should only spend maybe a couple hours and you can build out something along these lines. We started with what is a simple task. We have an endpoint. Go ahead and do something with the endpoint. Like that's as vague as some of these literally are. They want to see what your creativity is. They want to see what you're going to build of it. Or they'll tell you directly, build a master details type thing. And so all you do is you take that and you start breaking down the different components. You start structuring things out. The things that we focused on, first of all, keep in mind solid principles. If you don't know solid, again, go back and watch the episode on solid, then come back here. It'll make a lot more sense. And what you're doing is you're looking for, how do we break this down? First of all, starting with modularization. So we know that we're going to need a data layer or a networking layer. In fact, that networking layer the module could really be called data module. And then we just keep everything data related. So that might even include a repository if we went a repository pattern, repository and networking, and then keep those separate within different packages within that module. I just like calling it networking, especially when you're talking about a coding challenge. It's really easy for a interviewer to look at it and say, oh, I know what that is going to be. So the modularization, you're showing that you know and understand modularization just with simple couple of classes in there. Now, you also do a core UI to show that you know how to abstract out certain core components. You only have to do it with one. We only did it with the scaffold. That allows them, and that allows a talking point to say, we can also abstract out all these other components if we want to in here as well. And what we're doing is we're abstracting things out and we're using dependency injection. Very important. Always use the dependency injection framework. And at this point in time, and probably for the foreseeable future, use Hilt. That is the standard right now, not Coin, Hilt. It's very simple to set up, as I showed you here. Very easy to use, extremely powerful. Build your services with the solid principles in mind, the interface segregation, lives cost principles, and single responsibility. Break down those functions into one specific function. And then go ahead and map those out. In this case, we use Retrofit. But you also have the API service. And keep in mind, you want to abstract the API service in such a way that you could swap that out later in the future, or swap in a test service or a mock service. And the actual consumers will have no idea, or they won't even care. It's just going to build off of what it is there. It's not going to break the code. So then you can put in a live one or a whole different API service, a whole different library instead of Retrofit if you really wanted to. You can throw something else in there that handles it. You could throw in KTOR that handles it without having to go through and find all the places that you made the network call and change that. It shouldn't be structured in such a way that you would have to do that. You should keep all of that within the data layer and have it kick back a data response. That's important as well, is to highlight and isolate. And what we've done here is we have built out those layers and we've kept those layers separate. Again, single responsibility. Single responsibility is one of the most important things you're always going to come back to. So we have networking layer is going to go out and make a network call. It's going to come back. It's going to do something with that data, like in this case, a repository. So we store it so that we can use that data later. However, realistically, as we talked about the 304 caching, that's an alternative. Or you can build out a real repository instead of just keeping it in memory, because I already told you what the problem is with keeping it in memory here and how that will come back to bite us if we did that in production, but it's fine for a coding challenge. So networking layer goes out, hits the server, gets the data, and holds it. That's its responsibility. Now, you have a ViewModel, which is this nice bridge between the view and the data layer. It lives in the view layer. And we have these nice and organized packages over here in our view side. What we do, and that way each one of our screens are going to be built out with all of the components necessary for that screen right there. You might have certain composable components that are actually pulled out into the core UI. That's totally fine. Otherwise, have them live right there in the package next to where it's being used. That way, any future developer can come in here and say, screens, home screen. All right, I know that all my components are related to home screen right there. All right, details. I know all my components related to the detail screen right here. That's simple, including the models that are going to be used to propagate only that screen or only that component. So that view model acts as that bridge. So again, networking layer has the data. View model goes and says, hey, give me that data. Cool. It doesn't even care how it gets that data. Again, that's the abstraction. So there's a nice hard line here. It could care less if that's the actual API service or a mock API service or a test API service. It doesn't care. It's just going to get some data from that service. And that's the power of dependency injection. It's going to get that data. And now you have a data object, but it needs to be a UI object. So it maps that across that layer. That's what the view model is doing, is mapping that data, transforming it into what can be used for the UI side. And then the UI side just simply updates using Compose, because it sits there and listens, similar to how React does. In fact, it's reacting to those data changes, and it's of a state. So it is reacting to the state changes. So you're storing it as a local or as a state. The only property you want to have is mutable is the private one. Keep anything mutable private, encapsulate within the class as private, expose only a non-mutable version that anyone can listen to. Then the composables listen to those changes and it just renders out nicely. It's clean, it's simple. Always remember, implement solid whenever you can. If you like this episode, found it useful, go ahead and hit that subscribe button. I'm going to make many more like this. I'm also going to build onto this example. So I'm going to show you how to swap out that networking layer with something else. I'm going to show you how to implement certain serializations that you might want to use, or serializable. I'm going to go through and just keep building on these with the different components, because again, we built this in a modular way, so it'll be easy to do that. I'm also going to have an entire series just dedicated to more tips and tricks that I've learned along the way, my 10 plus years in the industry in senior level positions for the last 10 plus years. I've worked in small companies, startups, as well as several Fortune 500 companies. And I know what interviewers are looking for because I've been an interviewer myself, and I have interviewed at countless places. And I've submitted various forms or versions of this coding challenge I just gave to you, and everywhere that I have submitted for has returned an offer, a sizable offer. As always, if you want me to break down a specific topic we talked about here, or if you have a different topic you want me to talk about that I haven't even talked about here, go ahead and hit me up, DM me, or put it in the comments, and I'll go ahead and dedicate an entire episode just to you. So go ahead and hit that subscribe button. Till next time, stay awesome, my friends.